Finding the area of composite figures. When we find the area of composite figures, make sure that you have your formula sheet sitting out right next to you because you'll need to be using different formulas to solve these. When you solve them, the first thing you want to do is divide the area into smaller familiar shapes. Look for circles, look for squares, look for rectangles and triangles and trapezoids. Then you're going to find the area of each shape. After that, you add or subtract the areas to find the area of the composite figure. So in each one of these, we're going to be finding the area of the shaded region. So sometimes we're going to have to add to put it all together or subtract and take pieces out to find the area of that composite figure. For this first example, we have a square. You can tell it's a square by it has an 8 by 8 edge there, and then we also have a circle inside of the square. So I'm going to find the area of the circle first. So looking at my formula sheet, I know area equals pi r squared. So I fill in what I know, 3.14 times. Now, since here to here is 8, that means from here to here also has to be 8. So I need my radius. That's going to be half of 8, which is 4. So pi r squared, which is 4 squared. So area equals 3.14 times 16. So the area of this circle is going to be 50.24 inches squared. Now I have my square. Area of a square is side squared, or you can do 8 by 8. So side squared. So area is, that's a little 2, 8 squared. So the area of my square is going to be 64 inches squared. Now what I need to do is find the area of the shaded. So you'll notice that only the outside is shaded. So the area of the total, put a little t for total, is going to be, take the area of the square and then subtract out the area of the circle. So my final answer is going to be 13.76 inches squared. In number 2, you have these two figures, so one here and one here. You'll notice that you have a rectangle and you have a semicircle. This time the whole entire thing is shaded, so you're going to add it all together. So I'll do the area of the rectangle first, so the area of part 1, which is 12 times 25. Because it is a rectangle, it's length times width. So the area of this one is going to be 300 feet squared. So the area of part 2, remember when you're doing these, this is the most important piece for me. I have to see what numbers you are plugging in. So these are the most important pieces. Part 2 is going to be pi r squared divided by 2. So you're going to have 3.14 times, and again, since this whole thing is 12, that whole thing has to be 12. But I need just my radius, so it's from here to here, which is going to be 6. So 3.14 times 6 squared divided by 2. So area of piece 2 is 3.14 times 36 divided by 2. So the area of piece 2 is going to be 56.52. And since I have to add this all together, I'm going to do area of my total is 300 plus 56.52, which is going to be 356.52, and then it is feet squared. So sometimes you have to find the area of both pieces or a couple pieces and subtract. Sometimes you have to add them together. Looking at this next one, I see that we have a triangle. Whoops, forgot my pen part. Triangle here. And then we have 3 semicircles. 1, 2, 3. So we'll call that piece 4. So if I have 3 semicircles, you'll notice that since it's an equilateral triangle, all 3 sides are exactly the same. They're 4 inches each. I can actually find the area of one of my semicircles, so pi r squared divided by 2, so 3.14 times my radius of my semicircle, again from here to here is 4, so my radius is 2. 2 squared divided by 2. Oops. So the area is 3.14 times 4 divided by 2. So the area of this one piece is going to be, where do I have it? 6.28. Okay, since I have 3 of those same pieces, I'm actually just going to multiply this by 3 to get the area of all the circles. Keeps moving on me. So the area of all the circles are going to be 18.84. So I found the area of one semicircle, and I times it by 3 since I have 3 of the exact same shapes. So now the area of the triangle. You'll notice that if you look at your formula sheet, area of a triangle is 1/2 base times height. So area of piece 4 is 1/2 times the base of your triangle and the height. So base and height are always perpendicular to one another, meaning they form a right angle. So if you're looking here, the base of my triangle, let's clean it up so we can see. Okay, it is not working for me. Okie dokie. So the base of my triangle, you'll notice, is 4. And then the height of my triangle is that perpendicular distance in the center. You can see it's that dotted line, which is labeled as 3. So 1/2 base times height. So the area of part 4 of my triangle is 1/2 times 4, which is 2, times 3, which is 6. So I have the area of the 3 semicircles is 18.84. I have the area of my triangle. We're going to put it all together. So the area of the total is going to be 18.84 plus 6, which is 24.84. 84, and then my label is inches squared. So again, sometimes you put it all together, sometimes we have to subtract. For this whole page, we can see that it's all shaded in, so we're going to be adding all of these when we find our areas. In the next one, you can cut that apart in different ways. I have students that cut it here, where you see that dotted line, and here. So you have 3 different rectangles. I also have kids that'll go and say, okay, let me cut it here and then here. So again, 3 different rectangles. It doesn't matter. It doesn't matter how you cut it apart. As long as you use your formulas correctly, you will get the same area. So I'm going to cut mine here and here. And I'll just do piece 1, 2, and 3. They're all rectangles, so it's all length times width. So the area of piece 1, let's give ourselves some room here. Let's get this out of the way. I do not know why it doesn't want to erase on that side. So the area of piece 1 is 5 by 7. Hang on, I can't. It is not 5 by 7. I can't see it. There it is. 13 by 7. So 13 times 7. So the area of piece 1 is going to be 91. And actually, that's going to be the same as the area of piece 3, since this side here is 13, this side has to be 13. So the area of piece 3 is 13 by 7. So the area of piece 3 is 91. So let's look at the area of piece 2. So area of piece 2. I know that since this is 7 and this is 7, that's a total of 14. From here to here is 20. So 20 minus 14 gives me 6. So this piece is 6 right here. And then the height here is 5. So the area of piece 2 is 6 times 5. So the area of piece 2 is 30. So now we have to add all these together. So the area of the total is 91 plus 91 plus 30, which is going to give me 212 centimeters squared. This next one, I see 3 different shapes. Some students will notice this dotted line here, and they'll say, okay, well, I have 2 triangles, and then they'll see this one, and they say, okay, I have 2 trapezoids, but you actually have 1 large triangle, you have 1 rectangle, and you have 1 trapezoid. So there's only 3 different shapes. So we'll do 1, 2, 3. So the area, I'm going to erase this so I have some more room. The area of piece 1. So area piece 1, it's a triangle, so it's 1/2 base times height. Base and height are perpendicular, so look for the perpendicular distance between base and height, and it's going to be right there. So area is 1/2 times my base, which is 6, times my height, which is 4. So area of piece 1, 1/2 times 6 is 3, 3 times 4 is 12. So area of that triangle is 12. Area of piece 2, that's a rectangle, and you will notice that it is 6 by 11. So 6 times 11. So area of piece 2 is 66. Now area of piece 3 is a trapezoid. So for a trapezoid, this is the first time we've done this, so it's 1/2 height times b sub 1 plus b sub 2. Again, height and your bases are always perpendicular to one another. B sub 1, B sub 2. These are the two bases that you have. So I'll do it in green. Here's your base, and here's a base. Bases are always parallel to one another in a trapezoid, and then height is the perpendicular distance between it. So the area of this piece here, get back to my color, area piece 3 is 1/2 times height of my trapezoid is 6. B sub 1 is 6. B sub 2 is 18. It really honestly doesn't matter which one you call sub 1, sub 2. So you have 6 and 18. So area of piece 3 is 1/2 times 6 times 24. So area of piece 3 is going to be 72 inches squared. So in the end, when you add all these together, you have piece 1, which is 12, piece 2, which is 66, and piece 3, which is 72, gives you an area, total area is 150 inches squared. Now for the last one. This one is always tricky for kids to do. I would pause and see if you can figure out how to break this up. Okay, so in this problem here, a lot of students will break it up because they'll say, okay, I see some trapezoids, I see some triangles and things like that. The trick to this one is actually if you cut it right through there, you actually just have two parallelograms. So you'll notice on your formula sheet to find the area of a parallelogram, it is base times height. Okay, height and bases are always perpendicular to one another. So there's that and there's that. So here's parallelogram 1, parallelogram 2. So area of part 1 is going to be 4 times 14. So area of piece 1 is going to be 56. Ooh. 56 millimeters squared. Area piece 2, you have 16 times 3. So area piece 2 is going to be 48 millimeters squared. So the area of the total is going to be 56 plus 48, which is 104 millimeters squared. So when we're looking at composite figures, these are figures that are not actual shapes. Like here it looks like you have a rocket ship. Here you have like a boomerang or whatever. You have to break it apart into familiar shapes that you know, and you find the area of each of these shapes and you add it all together, or you subtract it depending upon what the figure looks like.